All right, two more multiple choice problems. First one is particle motion, which they give us the position of a particle such that time is greater than 0. And they're asking us that when acceleration becomes 0, the velocity is what? So we need to find the second derivative and find when that equals 0. So we're going to go ahead to the home screen on our calculator, and let's type in the function t to the fourth minus 2t cubed minus t squared plus 2. And then I want the second derivative, so I go to F3, differentiate, grab my function, comma t to differentiate with respect to t, comma 2 to take the second derivative. And now I want to know where this second derivative equals 0. So I'll hit the solve button. I have solve, grab it, enter, equals 0, comma t to tell it to solve for t. And I have two values. I'm going to do green diamond enter to see what they look like. So I have 1.145 and a negative value, which can't work because time can't be negative, or t can't be negative. So now I need the first derivative, and I'm going to evaluate it at this 1.145 value. So let's go back up to taking the derivative, and then I'm going to go up and grab my original function, which is here, the t to the fourth function, and I'll just differentiate it once with respect to t. And now I'm going to evaluate that such that t equals 1.145. And do you see how I'm going up and grabbing that whole line? And then what I'll do is I will erase the negative value. This way, I didn't round anything in my calculator. I used the exact value provided by the calculator. And my answer is negative 4.15, or A. All right, on this one, which of the functions are differentiable for all x? You basically need to think about where the function might not be differentiable. So on this first one, my question is it differentiable at 0? There's no way to make x squared anything less than 0. One way to handle this would be to take the derivative and evaluate it at 0. And I think I have questions at 0 for all of these because of the absolute value function. So one way to do it would be to graph and see if you have a sharp point or a cusp. Another way would be just to plug each one into your graphing calculator, which I think I'm going to do. I'll take x squared plus 1 underneath the radical, and I'm going to differentiate it. Let's see what it gives me here with respect to x. And the question is, can I ever get a 0 denominator out? And I cannot, because x squared can never be less than 0. So I can take this derivative. So this is good. That means it can't be b, it can't be d. So then let's try x times the absolute value of x. So I'm going to type in x times, and then for absolute value, I'm going to go to catalog, and the very first choice is ABS. So x times the absolute value of x. Now when I differentiate this guy, F3 derivative, pull it in, hit comma x. I have 2 times the absolute value of x. Let's see if we can do this at x equals 0, and we can. So this guy is differentiable here, so it can't be 1 only. It's either 1 and 2 or 1, 2, and 3. So let's try one more. We'll put in the absolute value of x times e to the negative x. And we will then take the derivative. So with respect to x, I'm taking the derivative. And this one looks interesting. Let's see if this even exists such that x equals 0. Plus or minus 1, I have 2 different derivatives. So 3 does not work, and the answer is C, 1 and 2 only.